Workbook page 43, continuing talking about simple interest. We deposited $3,500 into a savings account. Simple interest rate is 4%. How much interest will the account earn in 2 years? Again, the book's doing this a little bit differently. They just have a little bit different order and stuff there. So we'll use this equation, I equals PRT, that we've been talking about. Interest equals principal times the interest rate as a decimal times the time in years. So on this problem, the interest, how much interest they got is what we're trying to find. Principal is the $3,500. Interest rate is 4%. We need to change that to a decimal. So move your decimal 2 spots to the left is 400ths. And then the time is 2 years. So put a 2 in place of the T. And we'll just multiply those together. And that should come out to be $280. So in other words, they earned $280 in interest. And then if they asked what the account balance was, then we could just add $3,500 plus the $280, and we would see they would have now $3,780. So on part B, the question is how much interest will the account earn in 10 years? So that was in 2 years. We're trying to find for 10 years. And so basically, all of our information is going to be the same here, except that instead of a 2, we're going to put a 10. Okay? So, just modifying here. What you can actually do on your calculators, if you have the calculators we mostly are using, you can actually, if you just got your $280, you can actually just do your up arrow on your calculator, and then you can change the 2 to a 10 and then hit enter, and then you can get your new value. So if you look on the calculator screen here, I've got that entered in from what we did on part A, and then again you can just press the up arrow and then arrow over until you get to the 2, and then you can actually type over the top of that if you want, is going to be 10. If you would ever have to change anything in the middle of the problem, like, well, let's just say then if you did that, that would be 1,400. If you ever had to change anything in the middle of the problem, like if we had to change the 4%, let's say it was like 3.5%. Okay, if I start typing 3.5, I'm going to have to retype the rest of the stuff here. So the option you have actually is if you hit your second button and then the delete button has INS, that means insert. And then we can actually press the 5 and it'll move everything over instead of deleting what's in that place. So that would be a 3.5%. We could see what the difference would be there. So if we look at number 3, suppose Houston deposits $600 into a savings account with simple interest rate of 2.5%. Make sure you don't lose the decimal there if you're underlining. Okay, that's supposed to be 2.5%. He wants to keep his deposit in the bank long enough to earn at least $120 in interest. How many years should Houston keep his deposit in the bank, assuming he does not withdraw or add to the account balance, and explain? Okay, so once again we can start with our formula. I equals PRT, and there's 4 variables. Always we're going to know 3 out of the 4. The question is on this problem, how many years should he keep it in the bank? So that means that we're going to be trying to find the time. T is what we're trying to find, means we should know I, P, and R. So the interest is the $120 they're wanting to earn in interest. Principal is how much they're putting in the bank, which is $600. The interest rate, it was 2.5%. Move your decimal 2 spots to the left. So that'd be like 25 thousandths. And then the time, again, is what we're trying to find here. So to solve for t, the first thing we could do on the right side is we could multiply the 600 times 25 thousandths, which is 15. That cleans things up pretty good for us. And then we could say the variables being multiplied means we need to divide by 15. Good. Divide by 15, and you should get 8. And remember, this is the time in years. So that means 8 years. If they kept it in 8 years in the bank, they would get $120 in interest. Obviously, if they kept it in longer than that, they would earn more than $120 in interest. Number 4, Jill borrows $8,000 for college expenses. He will pay a total of $10,280 after 6 years. And he says the interest rate is at least 5%. Is he correct? Okay, so what we have to think about on this one is he's borrowing $8,000. When you borrow money, you're going to have to pay interest. Means you're going to have to pay back more than $8,000. So they're telling us altogether over 6 years he's paying $10,280. So $10,280, that's like the principal plus the interest added together. Okay, so first of all, if we subtract those, that's going to tell us how much interest he had to pay. So if you subtract, that would be $2,280. Okay, what that means is, again, he's paying over 6 years $2,280 in interest. We know it's for 6 years, and we know the principal, that's how much he borrowed, is the $8,000. And so that leaves us just with the interest rate to figure out. So we can actually figure out what the interest rate is and then see if he's correct or not. So the interest, again, is the $2,280. Principal, that's how much he borrowed in this case, is $8,000. The interest rate is what we're trying to find, and the time is 6 years. So to solve for R, over on the right side, we can switch our order. If you want to physically switch it, you can. Anyway, we could multiply 8,000 times 6. All these are being multiplied so you can rearrange commutative property. So 6 times 8 is 48, so that'd be 48,000 R. So to finish up then, they are multiplying, so we can divide by 48,000 on both sides. Those will cancel, gets the variable by itself. When we do that, that's going to give us our interest rate as a decimal, and then we're still going to need to move our decimal point over. So as a decimal, that would come out as 0.0475 or 0.0475. So if we move our decimal 2 places to the right, this is like 4.75%. If we think back on the problem, he said that the interest rate is at least 5%, and so we had 4.75%, so he is not correct. Okay, so some sentence about that interest rate only being 4.75%, it's less than 5%, something to that effect. Number 8, which of these would earn the same amount of interest as a $600 principal with 2.5% interest for 6 years? Select all that apply. Basically for these then, You just have to work them all out. So, I equals PRT, so $600, change the 2.5% to a decimal, times 6 years. And if you work that out, is going to be $90. And then the question is just which of these other ones are $90. So the first one, same idea, so 200 times 0.05 times 8, and that would be 80. A little bit different on the second one. I guess I'm going to number these because we're not having enough room to work all these out here. So that was number one. Number two is a little bit different because if you'll notice, that is 18 months, not 18 years. So if I go to set this up, I know 80 and 75%. That's a big percentage. And then the time. So we know there are 12 months in a year, so you could do 18 divided by 12, which would be 1.5. Generally speaking, I mean, if they gave you something that wasn't very nice, like 17 months or something, what you could do actually is just put whatever the months they give you over 12. So if 17 months, just put 17 over 12. You can actually just type that all at once in your calculator, because 17/12 might not be a nice decimal for you. Okay? In this case, yes, you could do 1.5, but not always going to be able to do that. Decimals won't always be very good. Anyway, if you work that out, that actually does come out as $90. So that one works. The third case, 250, 10% for 2 years. So that comes out as $50, which is not 90. If we do the fourth one, we've got $300, 2%, and 2 years. I'm getting a little bit sloppy here just because we're doing so many of these, but I equals that. That's why I know I'm just going to be multiplying all those numbers together. So that would come out as $12, which is not near enough. And the last one, we've got $225, 10% for 4 years. And that would come out as 90. So that one actually works as well. So it looks like our second and fifth options would be the ones that would work for that problem.